Assalamualaikum warahmatullahi wabarakatuh. So this is notes for topic 2, electromagnetism. And most of the slides were um, prepared by Dr. Junaidi. And I actually have also add up some slides. Okay. So electromagnetism. So the aim of this topic is actually to make sure that the student understand about what we call the electromagnetic principle. Why? Because the electromagnetism is a very important, because this concept of or this theory actually is used in most of electrical system, especially in construction of the electrical machine. And this theory, electromagnetism, is actually a link and a very important bridge between electrical and mechanical worlds. So maybe you all know that for electrical machine, for example, DC machine and AC machine, okay, they actually convert. They are using electrical energy and then use it to produce mechanical, meaning that the rotation. Okay, so this this actually can only be realized due to the utilization of or understanding of the electromagnetism. Okay, so actually electromagnetics is actually a lot we are using it in our daily apparatus. Okay, so we are this electromagnetic used in general electricity, of course, store memory, okay, in your SD card and so on, in your and then in your hard disk and so on. Okay, generate pictures on your television screen, diagnose illness, and also there are a lot of things that involve electromagnetism. So electromagnetism works on the principle that an electrical current through a wire, okay, generates a magnetic field. For example, in a bar magnet, okay, the magnetic field runs from north to the south pole, and in a wire, the magnetic field will form around the wire. So, for example, if you have a cable, the current is flowing inside the cable, so there will a magnetic field form around the cable. And the last one, if you wrap a wire in a metal object, okay, and then you actually the current go through the wire, so it actually will actually magnetize that object. So that is actually electromagnetic, meaning that we are using electrical energy to produce magnetic, okay, to produce magnet. So that is what we call electromagnet. So it's actually a difference between electromagnet and magnet, because as you can see, this is actually the magnet, okay. So magnetism is a force field that act on magnetic material but not on the other material. Okay, and you maybe are very familiar that if you have a what called a permanent magnet, so you will have two poles, which is north and south, and the field, the flux here, okay, we call this flux, will actually go out from the north and go back to the south. Okay. And then if you have a two magnet bar, okay, two magnet bar arranged, so if you put this one is a knot, okay, so actually they will actually repel, okay, oppose the same pole, okay. But if this magnet is a south pole, so it will attract. So that is one of the what we call the characteristic of magnet. Okay. So if you have a different pole, so it will attract. Okay, so meaning that the flux will go from north to the south, so it will attract each other. But if you have what we call a similar pole, so it will oppose, okay? And you can use what I call the flux, okay, the flux and the north, the pole, by using what you call the compass and so on. And this magnetic flux, okay, which is from north to the south, will actually can be measured by using what I call Webers or WB. Okay, so this one is the same, and this is what we call when you have a current. Okay, when you have a conductor here, and then the current is flowing inside this, so you will actually produce a magnetic flux around this, and the direction of the magnetic flux, okay, is actually you can use by using right hand screw rules. So your thumbnail will be your direction of the current, while your other fingers, okay, will actually determine the direction of the flux produced by the current. Okay, so this is what we call the right hand rules. And if, for example, a wire, a coil of wire is actually is winding up, okay, and then you have current flowing inside this cable, so and then you winding it up, the produce of the flux, the direction of the flux is perpendicular of this wire. Okay, so this one can be shown by using this. Okay, for example, like this. So if you have a cable, okay, but you are winding up the cable like a solenoid here, so it will actually produce a flux that is perpendicular to the coil. Okay, so this one looks like a north pole, and this one is the south pole. So it will act like a magnetic bar here. Okay, but the what I call the intensity of the flux is much weaker compared to the bar magnet. So to increase the strength of the flux, okay, produced, you can always put what I call a ferrous material inside the coil, okay, where it can actually concentrate the flux, okay, and so you will have a more stronger flux intensity. So the flux intensity or flux density can be measured by using this can be measured and also can be calculated by using this equation. So the flux density is B, and you can actually calculate by using this equation, where this is flux, and the unit is Weber, and A is the cross section of the area where the flux is flowing. Okay, so meaning that if you want to increase the density of the flux, what you need to do is to make the cross section to be very narrow and increasing the flux. Okay, and this flux density is measured in unit what we call Tesla. Permeability, or mu, is a measure of the ease of which a magnetic flux can pass through a material. Okay, and it is usually measured in the unit of Weber over cross section multiplied with the m, with the what we call this is meter. Okay, so permeability of the free space, we are usually referring as a mu O. Okay, so in the calculator, just type constant 33. Okay, so it will actually will produce the value of your mu O. So constant 33, your mu O is actually 1.256 power of -6. So mu O is the permeability of the air, okay, and mu is actually the permeability of the materials, and usually we are referring mu in terms of the relative permeability, which is we call mu R. So mu R is actually the ratio or the relativity of the mu of the material compared to the mu of the air. Okay, so mu for relativity permeability of the air is 1. Okay, while for the cast iron, and then there are a lot of other materials that we will actually discuss after this. Okay, so usually materials, ferrous material, we can actually conduct flux. Okay, produce flux is actually the mu R is always larger than 1. Reluctance. Reluctance is the resistance to flow of the magnetic flux. Okay, so this is actually similar to the resistance in the electrical circuit, where resistance is actually the resistance of the circuit to resist the current flow. Okay, so in this magnetic circuit, okay, the reluctance of the materials can be calculated by using L, which is the length of this material, okay, the mu, permeability of the material, multiplied with the cross section of the material. Okay, the symbol can either be using this or what we call S. Okay, so right now what we have learned, the similarity between magnetics parameters and also electrical parameters is actually flux. Okay, so actually flux is actually equals to the current, while the reluctance is equal to your resistor. So right now we have what we call voltage. So voltage supply, what is the equivalent of the voltage supply for the magnetic circuit? So actually the voltage supply of the magnetic circuit is actually we call what we call magnetomotive force, or mmF. Okay, and this mmF is actually can be produced by having a coil, okay, winding up over the what we call these materials, okay, and we and then conduct a current flow inside this coil, and this mmF, it is the symbol is F, okay, can be computed by using N I. So N is actually the number of turn. Okay, so this is F, and magnetic equivalent of the Ohm's law, you can use this one. So the flux is equal to force over the reluctance. Okay, in other words, in the Ohm's law is actually current voltage over the resistor.